y equals 1/2 minus 1/2 cosine 2x minus pi over 3. First step to solve this problem is to simplify and then identify transformations. The problem simplifies into, to simplify, we take out the 2 from both the 2x and pi over 3. That makes the problem 1/2 minus 1/2 cosine 2 parenthesis pi minus pi over 6. The next step is to identify each transformation in the equation. The first transformation is a vertical shift up by 1/2. Next, there's a x-axis reflection indicated by the minus sign. Then the 1/2 besides the cosine causes a vertical shrink by 1/2. The 2 inside of the cosine causes a horizontal shrink by 1/2. And then there's a shift to the right by pi over 6. The first step is to draw the default graph cosine x. Step is to shift the graph right by pi over 6. The next step is to shrink horizontally by 1/2. We shrink by 1/2. That also affects the asymptotes. The next step is to shrink vertically by 1/2. That gives us 1/2 cos 2 parentheses x minus first. And this is the graph. You can see we shrink by 1/2 and the amplitude has changed from 1 to 1/2. That is to reflect across the x-axis because of the negative sign. Negative 1/2 right here. It causes the graph to reflect across the x-axis. The next step is to shift vertically by 1/2 upwards. And it just moves the graph above the x-axis. And yeah, that's the first problem. Y equals 3 plus 2 sine 3 parentheses x plus 1. These transformations are vertical shift upwards by 3, a vertical stretch by 2, or horizontal shrink by 1/3, and then a horizontal shift to the left by 1. The second step is to draw the default sine graph. This is what it looks like. It has a period of 2 pi and an amplitude of 1. It's right here, right there. Next step is to do the horizontal shifts, and we have a horizontal shift to the left by 1. So we just move it over left by 1. The next step is to shrink horizontally by 1/3 because of the 3 right there. This basically just shrinks the graph down by like a third horizontally. The next step is to stretch vertically by 2. And we stretch vertically because the 2 is next to the sin. It is not the sign. It is not inside the sign. It's outside. So that changes the amplitude to and just makes it taller. And just goes makes it taller. The next step is to shift vertically by 3 upwards. So it just means move it up 3. This causes the peak of the graph to be at 5 and the bottom of it to be at 1. The middle of it is at 3. The amplitude doesn't change, it's still 2. to be 1/2 tan pi x minus pi. So first we need to simplify that and take out the pi. This gives us 1/2 tan pi parenthesis x minus 1. Okay, now the first step is to identify all the transformations. First, the 1/2 causes it to do a vertical shrink by 1/2. The pi inside the tangent causes a horizontal shrink by pi. And then lastly, we shift right by 1 because there's a -1 inside the tangent. Okay, so the second step is to just draw the default tangent graph. It looks like this. The next step is to shift right by 1 because of that -1 right there. It looks like this. The next step is to shrink horizontally by pi, which it looks like this. Step is to vertically shrink by 1/2. That looks like this. For problem 2, part B, it reads -2 tangent 2x minus pi over 3. The first step is to simplify this, which we need to take out the 2. That makes it -2 tangent 2 parentheses x minus pi over 6. First step is to identify original information. The negative sign causes an x-axis reflection. 2 causes a vertical stretch by 2. The 2 inside the tangent causes a shrink by 1/2 horizontally. And lastly, the pi over 6, which is negative, causes a shift to the right. And the next step is to draw the default tangent graph. It looks like this. It's got a period of pi. Its asymptotes are pi over 2 and -pi over 2. The next step is to shift right by pi over 6. This is what it looks like. We just move right by pi over 6. It moves both of the asymptotes to the right too. Next we shrink by 1/2 horizontally because of that too. So we just shrink relative to the middle of the tangent right there. The next step is to stretch vertically by 2. This is what it looks like. It doesn't really change much, but you can see it's just more stretched out vertically. And the next step is to reflect across the x-axis because of that negative sign from before. This is what that looks like. The goal is to find x right here on the side. The first step is to fill in all the angles since we already have two, 30 and 90. So we fill in the 60. Next, since we have 25 and we know 25 is the hypotenuse because it's opposite from the 90, the right angle. And we want to find x, so we set x to the opposite angle of 30. And since sine equals opposite angle divided by hypotenuse, we can write down sine 30. We can write down sine 30 degrees is equal to x over 25. Next, since we know that sine 30, since we know on the unit circle, sine 30 is equal to 1/2. Just fill in 1/2 equals x over 25. And then we could just solve algebraically. Multiplying both sides by 25. 25 over 2 makes 12.5 equals x. And yeah, 12.5. X equals 12.5. Part B for this is another triangle. It looks like this. Step one, fill in the angles. So we have a right angle. We have another one. It wants us to find x, and it's on the top. And we have hypotenuse on the bottom, so we can just use the same method. Filling in x over 13. Since x is the opposite from the angle of 60, we use 60. On the unit circle, we know that multiply both sides by 13. This makes square root 3 over 2 times 13 equals x. We also has a part C. It has a weird triangle like this. So step one, we rotate it so it's actually the right way. It's easier. Then we fill in the angles. We actually don't have the hypotenuse this time. We need to use the opposite angle and adjacent angle, which means we need to use tan. We also want to use x as O so that the multiplication is easier. And we set it up like this. X over 4 equals 1060. Since in the unit circle, 1060 is equal to square root 3 over 2 divided by 1/2. Simplifies into square root over 3. So we know that 1060 degrees is equal to square root over 3. We can just fill that in, making our problem x over 4 equals square root of 3. We multiply both sides by 4, and that makes x equals square root 3 times 4. Part D for question 3 is also a triangle. The hypotenuse, it looks like it is x. So first step, we fill in all the angles. The angles are actually 45 this time. And we want to find x, which is the hypotenuse. You use the same method. We write sin is opposite over hypotenuse. We write the opposite side of this 45 right here, which is 12. So you write x for the hypotenuse, so it's 12 divided by x equals sin 45. On the unit circle, we know that sine 45 equals square root of 2 over 2. This lets us fill in sine 45 as square root of 2 over 2. Then we divide both sides by 1 to flip it. So we can put x on top. We multiply both sides by 12, making x equals 12 times 2 square root 2, which equals x equals 24 divided by square root 2. This next problem is a statement. It says if tan angle equals 2 over 3 and angle is in quadrant 3, find cos angle. The first step, since we want cos, we use the identity tan squared angle plus 1 equals sec squared angle because sec. So first step is to evaluate 2 over 3 squared plus 1. 2 over 3 squared is 4 over 9. Plus 1 makes it 13 over 9. Next step is to solve for squared angle, which we just take the square root of both sides, which leaves us with square root 13 over 3. Cos yet because it's plus and minus. Since angle is in quadrant 3, that means cos is negative. Cosine is negative, which means that we can safely put a negative sign over 1 over cosine. We divide both sides by 1 to flip it. Negative 3 divided by square root 13 equals cos angle. Part B for problem 4 wants us to find tangent, sine, cosine, cotangent, CSC, and sec. It says that if sec angle equals 2, and angle is in quadrant 4. Wants us to find all five other trigonometric functions. First step is to find tan through the identity tan squared plus 1 equals sec squared. Since we know sec, we can just fill it in as 2, right? We 2 squared is 4. We minus 1 by both sides, making it 3. To get rid of that square, we take the square root of both sides. Since it's since the angle is in quadrant 4, tangent is negative. This makes tangent equal to negative square root of 3. Since we know tangent, we can easily find cotangent by putting tangent under 1. So cotangent is 1 negative 1 over square root 3. Since we know sec, we can also find cosine very easily by putting it under 1 using this formula. Putting in sec, we just flip them, and cosine equals 1/2. Now that we have cosine, we can easily find sin. We can find sin by using the sin squared plus cosine squared equals 1 identity. Fill it in with 1/2. 1/2 squared equals 1/4. Minus 1/4 from both sides to get 3/4. Take the square root of both sides, making it square root 3 over 2. We don't know the signage, but we do know the quadrant. And since we know the quadrant is quadrant 4, that means sine is negative because of the negative y, which makes it our answer is sine angle equals to negative square root 3 over 2. We can also find CSC easily by flipping that, making it negative 2 over square root 3. Now we have all angles. So this is what they all look like. Yep.